All right, let's do this. So hello, everyone. Welcome to today's Service Mesh Academy workshop. Today, we're going to be talking about enterprise PKI in the cloud native world, and we're going to be using Linkerd and Cert Manager. So today, I'm joined by Richard from JetStack. Let's go to the next slide and get acquainted with each other. So if this is the first time we're meeting, my name is Mate. I'm a software engineer at Buoyant, and I'm also one of the Linkerd maintainers. Been involved with the project for about 2 years now, maybe a bit more. You can find me on Twitter, GitHub, and Slack. And I'm super excited because today, like I said, I'm joined by Richard Wall from JetStack. How's it going, Richard?
Hi, thanks, Matty. It's great to be here. I'm a programmer with JetStack working on the Cert Manager team at the moment. I've been with JetStack for 5 years, I think, and I'm based in Bristol in England. I'm very happy to be here working with you, Matty, and learning a lot about Linkerd in the last week or two in preparation for this talk. So
I've learned a lot about Pkis, so feeling is super mutual.
Okay, so I'll move to the next slide.
Yeah, let's kick it off. So, okay, just to give everyone a bit of an idea about what we're going to cover today. So we want to basically show you the building blocks of how Linkerd and Cert Manager can be used to integrate your external Pki or an external issuer into your K3d environment. So before we get into the really nice part, which is the demo, we're going to have a quick recap on mTLS and certificates. We're going to be talking a little bit about identity and Linkerd just to set the scene and sort of have this model in our heads. And then Richard is going to talk a bit about Cert Manager and the problem that Cert Manager solves. And why managing identity is generally hard for enterprises, as opposed to a new startup or just any company that's a bit more lean. And yeah, finally, we're going to have not one, but 2 demos. So Richard is going to give a demo. That's not going to be super interactive, but don't worry, he's just going to show us how everything works. He's going to impart some of his JetStack Cert Manager knowledge that he's collected during his time. And then we're going to try and do what Richard has done in his demo on our own machines. So stick with us until the end. I think it's going to be fun. I've had a lot of fun prepping it. So, and yeah, as a quick reminder, if you're going to be following at home, we have a few prerequisites that are in place. So first, you should probably have a K3d Cluster running. So we're going to use kind K3d Minikube. I think I'm using K3d, and I think, Richard, you're using kind. So either of them will work.
Yeah, we haven't actually tested with Minikube, have we? So perhaps use one of the first 2 rather than the last.
Yeah. It should work, but fingers crossed it does. Yeah. But yeah, maybe use kind or K3d. I think it would be a bit better. And then make sure you have Helm installed and the Linkerd CLI. For the interactive bit, I'm going to be using Vault as an external issuer, but you can use something else. You're just going to have to change the manifest slightly. And yeah, the presentation will be available after the meeting, Arthur. And also, we have everything in the GitHub repository that is linked here. So it would be good for you to clone it and have it locally, just because we're going to use some of the manifests. And both my demo and Richard's demos are transcribed basically in the GitHub repo, so you can just follow along with the steps that we have. It's like a transcript. So if you get lost, if you can't follow along for whatever reason, presentation is recorded and you have all of the steps there. And yeah, I think we're ready to get started. So my 40-second intro to mTLS, that's not really 40 seconds. I probably shouldn't have written that. But for people that are not super familiar with TLS and mTLS as protocols, they're communication protocols, and their aim is to have secure communication between 2 parties. And the way mTLS works, I'm just going to focus on mTLS. The difference between TLS and mTLS is that mTLS will go both ways. I'll expand on that in a little second. But basically, mTLS as a communication protocol works through asymmetric cryptography. You generate a key pair, you have a public key and a private key. One encrypts, the other decrypts, and that's how everything gets encrypted over the wire. But mTLS as a protocol has a little bit more than that. It makes a really good guarantee about security because it forces identities to be authenticated. So if I talk to someone online and we encrypt our communication, there's nothing that will basically prevent me from connecting to someone else who's pretending to be the person I thought that I'm connecting to. So mTLS sort of tries to solve this problem by introducing certificates and asymmetric cryptography to verify the identity of the parties. And when you verify the identity and you encrypt the communication channel is secure. mTLS as a protocol is also implemented on top of TCP, which makes it super versatile and flexible. Because I think, at least in my experience, most of the web services or systems that I've dealt with had traffic that was TCP. And mTLS basically works on top of TCP, which means it works with any layer 7 protocol, HTTP, gRPC, so on and so forth. And finally, what's really cool about mTLS is that because it uses certificates, it gives us this cryptographic proof of both client and server identities, which enables us to do a lot of cool stuff, such as authorizations, which lead us further down into zero trust networking and not trusting the network implicitly and not trusting anybody in the cluster. So it's a really good protocol for security. And especially in the cloud native world, it seems to be the best way to achieve zero trust security.
And it comes for free. It comes for free with Linkerd.
It comes for free out of the box. Yeah.
Important to say that. Can you imagine setting this up on a per application basis?
Well, the spec is pretty hard to read. That's where I usually direct people. If you have any questions about TLS or mTLS, read through the spec, but the spec can be a bit heavy to grok, and it's also a bit underspecified. So if you have to implement it, then, you know, I'll shed some tears for you, because I tried to implement it and it was a bit difficult. Anyway, let's move on to the next slide. So before I sort of go deeper into the identity model that we have in Linkerd, let's talk a bit about certificates and what they are. Really quick, 40 seconds again, not 40 seconds. But certificates are just data structures, right? They're data structures that contain a name or an identifying piece of information. We're just going to use a name because it's simple to understand, and a public key. The public key is basically bound to the name once a certificate is signed. Certificates, though, they're a good way to share public keys around and a good way to sort of share all of this information so that you can do mTLS, but they require a guarantee of trust. So when you have a certificate, you want to trust that the public key actually belongs to the name. There's nothing stopping someone from creating a certificate with, you know, a bogus name and their public key and pretending to be another entity. And because of that, we rely a lot on trust layers when it comes to certificates. So a certificate is going to be signed by another certificate, who in turn is going to be signed by another certificate, and so on, until we reach a certificate that we sort of unanimously trust, all of us in a company, all of us in a system. And generally, these certificates are either created by yourself, so you bootstrap the whole identity system yourself, or they're, you know, elicited by an organization that everybody in the world trusts. So that's sort of how trust and certificates come together, and that's what we say when we say that a certificate is signed. We say that it's been signed by another certificate, and because we trust that one, we also trust this one. So if that doesn't make sense, then, you know, I'll gladly explain it. But yeah, sorry, can you go back to the previous slide? Just want to say a few more things about this. So with Linkerd, we generally have a different operational model than people are used to. We don't just generate TLS certificates for the workloads. We also have a certificate authority, a CA, which we call the trust anchor. And that's the one in the middle that you see in this diagram. And the CA then is created by us. We trust it. And it creates 2 other or 3 other certificate authorities, 1 per cluster. And each certificate authority in a cluster will be called an issuer CA, or identity issuer in Linkerd terms. And this will actually be responsible for creating all of your application certificates. And the way we adopted this model is, first of all, for security. The root certificate is used only to bootstrap identity issuers. So its private key, in our opinion, should never be mounted to pods. It should not really be a thing that pods are concerned with. So you cannot really have a big attack surface there. And then each issuer certificate is also only mounted by our own identity service, which I'm going to talk about in a bit. So by basically having this model, we make it easier to revoke, rotate, renew certificates, and make sure that when a key gets compromised, it doesn't actually affect the whole trust chain that we have. And now I'm ready for the next slide. All right, so I mentioned that we have an identity service. And I quickly want to touch on this just because I think it's important for people to understand why we go through all of this complexity of managing so many certificates in Linkerd. So in this diagram, we have the bottom half, which is what an operator or a user typically sees. You have your own application. You have a client and a server. Client connects to the server. You inject them with the Linkerd proxies, and you get mTLS now. The first step, the application sends traffic to the target. The proxy intercepts the traffic. It sends to the target. The target also has a proxy. So the proxies basically talk to themselves. They do mTLS, and everything is secure. But under the hood, things are a bit more complicated. So when a proxy first starts up in its life cycle, the first thing that it does is it talks to our identity service, which is part of the control plane. And it does so because it wants to acquire a certificate. It doesn't yet have a certificate. It will acquire one. So the proxy first generates its own key. The key pair never leaves the pod, so the proxy certificates cannot easily be stolen, basically. And after it generates its own key, it connects to the identity service. It does TLS. It doesn't do mTLS because at this point it doesn't have a certificate. It talks to the identity service, verifies that it is who it is supposed to be, and then it sends a certificate signing request with a service account token and a service account identity. These are then validated by the identity service, so the identity service can be sure that this pod has access to the right token and the right identity, and everything falls into place. And after that, it generates a certificate, it sends it to the proxy, and the proxy does this every 24 hours. There's a bit of a caveat here because I say it does it every 24 hours, but in fact, it will do it even sooner if the identity issuer certificate is going to expire. So if the identity issuer expires in 6 hours, the proxy is not going to have a 24-hour certificate. It's going to have a 6-hour certificate. And the identity service is the only one that uses the identity issuer certificate authority that I mentioned earlier. So if this is a lot to sort of take in, don't worry, we're going to go through it again. Just wanted you to have a bit of context into what's happening with Linkerd, but I think things should be a bit clearer as we go along. Before we go on, do we have any questions? So I actually do see some questions on Slack, and Arthur asked, can the CA be part of our company Pki? Yes, and I think Richard's going to show that, so I'm very excited. Do you want to say something, Richard, or do you not want to spoil it yet?
No, yes, it can, Arthur. Sorry, I can't see the questions at the moment, but that's what we're going to demonstrate. In a moment, we're going to demonstrate having the Linkerd use a root certificate which has been signed by a CA which is managed outside of the cluster in a software called Verify TPP, or it could be Vault, as Matty's going to demonstrate as well.
Yeah, any external.
Yeah, quite possible. Yeah.
And then Arthur also asked, is it possible to secure traffic without the proxy sidecar in Linkerd? No, not at the moment. Probably it's not going to be a thing that's possible just because we rely on the sidecar to actually run the proxy and do mTLS. But I see Catherine and Charles are also going to reply to that question. So if people want more detailed answers, do have a look on Slack. But anyway, Richard, I'm going to hand it over to you now to tell us why Cert Manager is such an amazing project.
Thanks, Matty. Yeah, so this is going to be a whistle-stop, a couple of slides, just giving you an overview of what Cert Manager is and what it does and how it fits into the scheme of things, how it fits into this demo. So yeah, Cert Manager is an add-on for Kubernetes, and it originates from a project by JetStack called kubelego, which was solely concerned with running inside a Kubernetes cluster, looking at ingress resources inside the Kubernetes cluster, and based on its examination of the ingress common name and DNS names, it would go off to Let's Encrypt, create a private key, sorry, go off to Let's Encrypt with a certificate signing request and get back a signed certificate, which it would put in a secret along with the private key that it had generated. And that's all it did. It was a link between Kubernetes and Let's Encrypt. And then I think it's about 4 years ago or 5 years ago, we rewrote it, and kubelego became Cert Manager. It was rewritten in a much more modular fashion, so that it could do that core duty of creating a private key, sending a certificate request to a certificate authority, and getting back the signed certificate, putting all the TLS assets into a secret. But it would, we wrote it in such a way that it would integrate with not just Let's Encrypt, but any Acme compliant server. And not only Acme servers, our API is extensible, so you can create. We have created issuers, as we call them, to integrate with HashiCorp Vault and Verified TPP. But there's also the concept of an external issuer, which allows any company or organization to write a small controller which runs alongside Cert Manager, which handles the integration between Cert Manager and the CA and their particular CA. So, for example, there are such external controllers for integrating with Google Certificate Authority Service and with the equivalent Amazon Pki service. And we've also at Jetstack had examples of clients coming to us who are writing external controllers for their own private internal bespoke CA API. Anyway, Cert Manager is a controller inside Kubernetes, and it integrates with all sorts of CAs, and its core duty is to sign a certificate, create a private key, sign a certificate, and put the whole lot into a secret where it can be consumed by a pod or by an ingress. And it does still have a thing called an ingress shim, which allows it to still monitor ingresses, and when it finds an ingress with particular annotations that are of concern to Cert Manager, it will take from the annotations the common name that is required for the certificate and the issuer that should be used to sign the certificate. And with that information and other information, it can create a certificate and then go through the process that I originally described. So that's the overview, and the diagram. This diagram is from the Cert Manager website.
I have a quick question. Sorry, I'm interrupting you, but
no,
so just for the audience to know, Cert Manager can also bootstrap its own identity in a cluster, right? So what I used to do, for example, is create my own self-signed certificates whenever I use Cert Manager with Linkerd. So that's also something that Cert Manager supports. It's not just integrating with external issuers or
that's right. Yeah, and of course that's important, because that's the technique we're going to be using later in the demo. So yes, so Cert Manager can create a self-signed certificate, put that in a secret, and then there's a different type of issuer called a CA issuer, which you create as a custom resource in the cluster, and you point it at that CA secret. And then when you create other certificates that you want signed by that certificate authority, it will take the private key and sign the certificate request of the sub certificate, the leaf certificate, or a sub CA.
I have another question for you from Arthur. Does Cert Manager run as an operator, or is this a normal pod that has access to the K3d API?
We consider it to be an operator. Consider it a TLS operator, or a Let's Encrypt operator, if that's the issuer you're going to use. But it does run it does have three components, each of which run in pods inside Kubernetes under the supervision of deployments and replica sets.
Yeah, the Kubernetes way, basically.
Yeah. So yes, it is an operator. It's one of the, I think we could say it's one of the original operators. It's a relatively old and established project now, and very widely used, I should say that. So yeah, there's one more slide on this. It's just to summarize the duties of and the capabilities of Cert Manager. So I've told you that it creates TLS assets for workloads in Kubernetes, but it also gives you a certain amount of control over who can create those assets, because a certificate is a custom resource. And I'll assume everyone knows what a custom resource is. And just like any other custom resource, you can use RBAC profiles to control which users have permission to create certificates or update certificates or delete certificates. And so by that mechanism, and by the fact that the certificates are namespaced, and the issuers versus cluster issuers, issuers are also namespaced. You can control who has access to create certificates and which certificates have permission to use which issuers, i.e. the connections to external CA issuers and authorities.
Before you go on, I have another good question for you. Can Cert Manager auto-mount certs to the proper path inside a container? So for example, with a Debian-based container, can you keep the CA certs in different location than the actual host?
As in the trusted CAs that Debian.
I think so. Yeah, I think that's what it refers to.
Yeah, you can. I mean, you can mount. So you would mount a so Cert Manager, when it creates the secret containing the private key and the signed public certificate, also adds a file called ca.cert to the secret, and that's the certificate of the issuer of the upstream CA. And so that's the CA that you probably want to mount as into the Debian trust location. But there's a point. The problem with that is that you don't necessarily, the workloads that need that certificate to verify a peer shouldn't necessarily have access to the private key and the associated certificate that goes with it. I'm kind of muddling my words. It's complicated. Like usually you don't want to make that secret available to the workloads that are going to need to verify the secret. So that's where this project called Trust comes in, and that's going to be part of the demo shortly.
Cool. I think that answers the question. It answered it for me. So yeah, let's keep going.
Yeah, so then the other 2 points. So by default, Cert Manager will create a private key and it will put it into a secret in Kubernetes. And you don't necessarily want that. Secrets are not the content of the secrets in Kubernetes are not encrypted, and unless you have really locked down access to those secrets, it might be safer not to put private keys there. And Cert Manager has another add-on project. What I should say is that Cert Manager is the main operator, but we have a whole suite of add-ons which we recently put onto the Cert Manager website under the heading add-ons, I think, or other auxiliary projects or something like that. Anyway, there's such a project called Csi Driver, which allows you to create a pod which you configure to use this Csi driver, and what it does is that it will provide in a particular configured path in the file system mount namespace of the pod. It will automatically create the private key there and only there, so it doesn't need to create a secret with that private key. And it will, in addition to that, it will create one of these Cert Manager custom resources called a certificate request. And once that has been created, Cert Manager can take over. It sees the certificate request, it gets it signed, it populates the status of the certificate request with the signed certificate data, And then the CSI driver running inside the pod can take that signed certificate and put it on the file system alongside the private key. And so, that is a way of restricting access to private keys. And then finally, and quickly, I'll say that Cert Manager has a whole suite of metrics that you can probe using in Prometheus format. And so that and other mechanisms in Cert Manager allow you to see more clearly how many certificates you've got, how many of them are approaching expiry date, how often they're being refreshed, and generally you might get a much better picture of how your certificates are evolving in your cluster. So that's the end of my slides on Cert Manager. Is there any questions to answer on that, Matty, or shall I carry on?
I think you can carry on.
I'll carry on.
We've answered a lot of questions in chat too, so yeah, just carry on.
Okay, so the next part of the presentation that I'm going to talk about, the theme of this demonstration, or these demonstrations, is they are jointly Buoyant and JetStack trying to address the friction that occurs when an enterprise, an established enterprise company with an established Pki team, start adopting new cloud native technology like Kubernetes. And so let's first talk about these two imaginary groups, or they're real groups. These are from our experience at JetStack, and I'm sure from your experience at Buoyant, we in our field teams encounter these when they go to an enterprise, they encounter a Pki team who are well established, and they have developed a set of policies for the whole enterprise, which it might include things like the type of certificate encryption algorithms that are used across the company. They might have established infrastructure, and they may have already adopted some enterprise Pki software, such as Vault or Verify TPP. And their job, one of their jobs, is to ensure that their processes and policies and best practices are followed. I've put best practices in quotes because it's different from team to team. And then you have the group of people, or groups of people, who are trying to bring in the new technology like Kubernetes and Cert Manager and Linkerd. And they're busy creating clusters. They're busy automatically deploying workloads to those clusters, setting up mTLS with Linkerd, and wanting to monitor and maintain all those applications. And with all of that new infrastructure, and with all of those new and dynamic workloads, there's a sort of explosion of new certificates, TLS assets that the Pki team start to worry about. They want to know what's going on. And that brings me on to the next slide, which is about two examples of the friction that occurs between these two groups. So the platform teams are wanting to move fast, and they're adopting all these new technologies, but at the same time, they know that they have to apply and enforce the policies which have been dictated by the Pki team. So the question is, do they have the tools they need to do that? And then from the point of view of the Pki team, they are often troubled by this explosion of new TLS certificates that they are vaguely aware of, being vaguely aware that these TLS artifacts exist inside multiple Kubernetes clusters and used by multiple meshes and workloads. And they want to know where these artifacts are, what they look like, what are the characteristics of those TLS certificates, and whether they match the policies that they've set down. So this is the crux of it. JetStack and Buoyant have been thinking about this, and we're trying to, amongst other things, we're trying to make life easier for those two teams, trying to make it easier for them to integrate their respective suites of software. And we look at the points of friction, for example, the two items that I described earlier. We try and find ways, find existing ways to integrate our software, which is what our demo is going to be about. And most importantly, we're constantly trying to find new and improved ways to smooth the integration between all of these systems. And I think that concludes my talk.
Yeah.
Matty, are there any questions?
Currently the chat is empty, so I think we can just move on. We'll give people a second to gather their thoughts. There's a lot of things to think through.
So your slide follows on from that point, doesn't it? This is about the integration potential of Linkerd.
And it's more knowledge and more resources. And you're going to get a bit confused because we're going to use the word root quite a few times. So there's gonna, a lot of roots are going to be taking place over here in this diagram. But what I wanted to show before Richard starts his demo, what we're basically going to do today is install Linkerd with the 2 certificates that it requires. So for people that are not aware, generally when you install Linkerd, you have to provide these certificates. And we're going to do it without providing them to Helm or to the Linkerd installer. We're actually just going to bootstrap them using Cert Manager and an external Pki. So in this diagram, whatever you see in the box is a Kubernetes cluster. So that's an environment that we have set up. On the left, we have some keys just to make the diagram a bit easier to understand. So everything that's marked in green is a Cert Manager certificate resource. And a certificate resource is just a declarative syntax. It's basically, like Richard said, a custom resource that you write, and that represents a certificate. So you write that, and Cert Manager processes it and submits a CSR based on it. Am I correct so far, Richard?
Yeah, correct.
All right, cool. And then we're going to have a Cert Manager issuer resource, which is going to be marked in purple. The issuer resource itself will be responsible for communicating with the external Pki in this case, and receives those CSRs for certificates. It's just going to be, again, a declarative syntax. It's going to say, okay, hit this endpoint, sign certificates in this endpoint, and then create the resources or whatever Cert Manager does under the hood. So that's going to be in purple. We're going to have blue, which is a K8 secret, and the red, I think it's red, is going to be a normal K8 spot. So the way we start is from the left. So we have an external Pki. We have an external issuer. In this case, we can assume it to be Venafi TPP or whatever else you would use. And this Pki has a self-signed CA that was bootstrapped inside. So this could be something that maybe signs all of the certificates in a company, ingress certificates, webhook certificates, so on and so forth. So you have like one central authority that just signs everything to sort of achieve that trust boundary that I talked about early on in the presentation. So we're going to have that external thing. We're going to create a Cert Manager issuer resource. This is going to send all of our certificate resources that we create over to the Pki to sign them. So the next step will be to actually create a root trust anchor for Linkerd. And that's over there in step 2. You can't actually see my mouse pointer. I'm moving it on my screen, but I just realized you can't see it.
Can you see my mouse?
Yeah, there we go. So we have the trust anchor. That's going to create a certificate that we're going to use to bootstrap the rest of Linkerd's identity. So that's going to separate the trust boundaries a little bit. Going on to step number 3. After we create the certificate, Cert Manager is going to give us back a secret. We're going to call it Linkerd Identity Trust Root. I abbreviated Linkerd because I didn't want to make the boxes too big, but that L5D is Linkerd. And this secret is going to have the CA, which is going to be the one we have in the external Pki. It's going to have Linkerd's new CA certificate, and it's going to have the private key for that. Now, we don't actually want to do anything with the private key, so we're going to start branching out here. So first, we're going to create a Configmap with Trust, another tool that we're going to introduce soon. And this Configmap will be used to install Linkerd, and it will only contain the public information from the certificate. So we basically keep the secret in the namespace. We don't touch it ever. We don't mount it to anything. But instead, we take its public information and put it in a Configmap so we can mount that freely without having access to the private key. In step 4.1, which is down below, we use the same secret to create another issuer for Linkerd, and this issuer will sign Linkerd's identity issuer certificates. So like I said, lots of issuers, lots of identities. But what this means is that we have a new cluster issuer that's going to receive resources to bootstrap Linkerd's intermediate CA. And after this, with the intermediate CA, we can mount the secret that will come out of it into Linkerd's identity service and start issuing certificates for our proxies. And before we go on to the actual demo, I do have a question from Arthur, who asks, for internal and test purpose, can I use my self-signed CA to integrate it with LabK with Cert Manager? And yes, you can. A lot of people do that. You can have your own self-signed CA, and it's actually what we would sort of recommend. It's what we recommend in normal Linkerd installations. But for this demo and for the purpose of this presentation, we're focusing on the enterprise side of things where you already have a Pki in place. So you don't need to have a self-signed issuer.
I think there's a page in the Linkerd documentation about that, isn't there, Matthew?
Yeah. I'm actually going to link that. So I think this sort of concludes the diagram and what we're going to do. I just wanted to give you a bit of an overview before we start working with it. So yeah, take it away, Richard.
Okay, thanks. So how are we doing for time? If I try and get my demo done in 20 minutes, that should leave you plenty of time, Matty, for your more interactive session. So let me crack on. First, if plenty of time, good. So everyone here should have received the link to the GitHub repository, which I've got on my screen. And for this demo, we're going to be following the steps in the Pki workshop-venify-tpp directory. And so you can follow these at home. You can follow these steps at home and look at the. In particular, you can look at the YAML files that I'm going to be applying during the demo. There's a little bit of an introduction in the README, which basically covers the same ground as we've covered in the slides earlier. There is a little description of the 4 pieces of software that we're going to use for this demo. I should dwell on that for a moment. So I've dropped this term TPP into the conversation so far, and what TPP is a piece of software from JetStack's parent company, Venify, and it stands for Trust Protection Platform. And this is an example of an enterprise Pki solution. And it has a nice web UI, and it has a very rich REST API, and it's also quite pluggable. So it has a lot of integration potential. And I'll show you it in a minute. We have Cert Manager, which I've already described. We have Linkerd, which I think you're probably all familiar with. And Matty has just explained its integration points for this demo. And then we have this side project in Cert Manager called Trust, which does a very specific job, which we'll come to later. If we scroll down, if you're looking at this content at home, you'll see a diagram. It's my attempt at the same diagram that Matty has illustrated much nicer in the slides. So we'll skip past that and we'll go straight to the steps. So the first thing we need is a cluster. And in my demo, I'm using kind. And I have actually, if I just clear my screen, I've got this running already. So I've also got kubectl, so I can check that the cluster is accessible. And I can just check that it's pretty empty at the moment, just the control plane pods running. So we're starting from a fresh cluster on my laptop. Kind runs the cluster as a Docker container. So you can see the Docker container running there, inside of which there are multiple other container isolated processes running. So we have a cluster, and we can skip that step. The first thing we need to do is install Cert Manager, and there are various ways to do that. all documented on the Cert Manager website, linked to here. But for this demo, we're going to use the Helm installation method. So let's copy that and paste it into the terminal. And that'll take a minute or two to install. It's downloading the images from the Cert Manager registry on Key.io. And once that has finished, we can use another tool, the Cert Manager command line tool, to check the status of the Cert Manager components. We could do that here in the bottom pane. So I do those one at a time. First of all, we see that Cert Manager 1.8 is installed, and then there's another tool to check the status of the Cert Manager APIs. So that all looks good. So now we're moving on to the first setting up and creating the first certificate in that diagram that Matti presented. And this is the first thing we're going to do is set up Cert Manager so that it can connect to Venafi TPP. And before I do that, let me show you Venafi TPP. Let me log into it. So this is the web UI, and while that's loading, this is the REST API with which Cert Manager interacts. So in the web UI, you can see that one of the main concepts in Venafi TPP is that of a policy tree, a tree of policy folders. And I have created a K3d folder within which I've created a cluster folder. And each of these represents or can represent a different policy that is applied to the certificates and identities within it. And so if I click on the certificate tab, you can see that this certificates in this policy folder are going to must have the ECDSA key algorithm, and another key point is that they will be signed by this using this so-called Csi template, which actually represents one of the Csi templates inside the Windows server on which this software is running. And it's a template that I created by going into the Windows UI and clicking around and creating a template that allows me to sign certificate requests for certificate authority certificates. Normally those, if I send a CSR, a certificate signing request, which is marked as a certificate authority, Windows would require manual approval of that. But I've made it a separate template which allows them to be automatically approved for the demo. Okay, so that's a quick quickly showing you what TPP looks like. And now we can go back to our instructions, and to connect, for Cert Manager to connect to the TPP REST API, we need to it needs a set of credentials to authenticate. So what we do is we put those into a secret inside the Cert Manager namespace in this instance.
Richard,
and
real quick. So
with that in place, sorry, is there a question?
Sorry, I'm interrupting, but real quick, we have a question if you can show the certificate details that you generated in TPP. Is that possible at all? Just so we can see what that root CA looks like that we've generated, or should we just leave that until?
I could show you the details of that certificate template, but the one I really want to show you, we will see later. So okay. In a moment, we will get Cert Manager to create a new intermediate CA, which represents the root CA in our lingo. The root the root-most CA inside Kubernetes. Shall we put it that way?
Yeah, yeah. The root CA from now on is the root NK. So that's it.
Right. And so but before we do that, we have to set up this Cert Manager issuer, which I better speed up because I'm running out of time. We're going to point this. We're using this resource to tell Cert Manager that we want the certificate to live in this policy folder, and we also include the URL of the REST API. And I've got that in an environment variable in my shell. So let's apply that. So this is our first interaction with the Cert Manager API. We've created what's called a cluster issuer resource. And then Cert Manager, you can use all the usual Kubernetes kubectl tools to investigate that, the status of that resource. So we can wait for it to be ready. And if it's not ready, then this is hopefully not where the demo goes wrong. We can investigate why it's not ready. Hang on. Oh, I know what I did. Sorry, I didn't do the env subst thing. What I should have done is this. And what that did was filled in this URL, which is a URL to my particular TPP server. Sorry about that. So
live demos are hard.
Describe it again. We can see that there's two events, the original error, and now having corrected the URL, Cert Manager has re-reconciled the issuer, and it's now reporting as ready. So we can continue. Phew. Okay. So now we've got this issuer resource, and what we can do now is create a certificate which will reference that issuer resource. And this is going to answer that question that you had a moment ago. This is where we're going to create a TLS certificate with this common name, the root.linkerd.cluster.local, and it will be a CA certificate. So this is an example of the Cert Manager certificate API. It represents the desired the certificate that you desire, and Cert Manager will see this, and it will try and bring that into existence in the secret that you specify here. So let's apply that. Okay, and to check the status of this, we can turn to the Cert Manager command line tool. Let's just do those one at a time. So the first command examines the certificate resource, and it looks to be ready. It gathers together all the information that's available about that certificate, the secret that it saved this TLS information to, and the issue and the status of the issuer that was referenced by that certificate. And it all looks okay. And then there's a second command which allows you to inspect the TLS content of any TLS secret in Kubernetes, and we can use that to get somewhat overlapping information, but it does include information about, it tells us that this is a CA certificate, which is what we hoped for. So now we should be able to turn back to Venafi TPP and see that certificate in the web UI. Let's just check. So if I go to the policy folder and refresh, there it is. So we can see that our certificate has been signed by this root certificate inside, actually inside Windows, inside the Windows server on which Venafi TPP is running. And so it's not the best example of giving the Pki team visibility, but it is an example of how you can achieve that, and it does give them some degree of visibility on what's going on inside these clusters. And I should say that there's a whole bunch of tools that Jetstack produce which make this even better. So it allows you to synchronize all the certificates from a Kubernetes cluster into TPP so that you get full visibility. but this is the aim of the demo. Right, so let me go back to the instructions. So now we need to create one more CA certificate. This is the CA certificate that the Linkerd identity component will use to sign the leaf certificates for its proxies. And to do that, first we have to set up one of these CA issuers, which we touched upon earlier. So you can see the YAML here, gives the cluster issuer a name, and it tells Cert Manager which secret it can find the private key with which to sign certificate requests targeted at this issuer. So let's set that up. And once again, we can check the status of that issuer as follows. And that is ready and verified, so we can continue. And finally, we're getting to the interesting part. What we're going to do now is create the Linkerd namespace, and we're going to pre-populate it with those certificates that the Linkerd installer needs to set everything up. Those certificates that it would, under normal circumstances, bootstrap itself, it will find in existence already and simply use those. So we create the Linkerd namespace, and we create another certificate, this time in the Linkerd namespace, referencing the CA issuer that we created a moment ago, and ask Cert Manager to put the signed TLS key pair into this secret, a secret with this name. And the name is important. Linkerd, if it finds a secret with that name, will use the contents of it. So let's set that up. And we can once again check the status of that. And it all looks okay. There's a certificate with the correct name issued by the root. And if we do the inspect command, we can see that this too is a CA certificate. So that all looks good. The Linkerd identity process should be able to use this to sign the leaf certificates of the proxies. We're not quite ready to install Linkerd yet. We now need to create this config map that Matty described earlier. And to do that, we use this project called Trust. Let's install it using Helm. The documentation is on the Cert Manager website. I'll quickly show you the installation documentation and the usage documentation. And once it is installed, it will have created its own set of custom resources. And the one we're going to use is called Bundle. And it's a way to tell Trust which secret to copy files from, and which secret to copy files from, which file to copy, and where in the target config map to copy it to. So we're going to ask it, we're going to configure it to open the Linkerd trust root secret, copy the TLS cert from it, and put that into a file called ca-bundle.cert in a config map in every namespace in the cluster, which is what Linkerd requires, because it then mounts that config map into the pods that are running the sidecar proxies, so that they can verify their peer connections using that CA trust bundle. Anyway, let's do it and see if it works. Okay, and we can check that out as follows. Make sure I get everything. There's 3 commands here. I'll run them, and then I'll run them one at a time. So we can describe the bundle, and the events associated with it tell us that it's been synced. We can describe the config map that has been created and see that inside it is this certificate material, PEM encoded certificate. And then we can, if you've got OpenSSL installed, you can extract that file and run it through OpenSSL and just check what content is in there. And we can see that it's a CA certificate and that it, oops, let me scroll up, that it has been, remember, this is the root certificate inside Kubernetes, which has in turn been signed by a root certificate in Venafi TPP. So it's issued by Venafi, but this is it's an intermediate certificate, let's say that. Okay, so now I think we're ready to install Linkerd. And if we want it to use these existing TLS secrets, we need to pass it two important command line flags. The first tells it to use the Linkerd identity secret, tells the Linkerd identity component to use that secret for stamping and for signing the leaf certificates. And then this second parameter tells Linkerd to set everything up, set up all the proxies to use CA certificates, which are handled externally in a config map. So let's do that. And while it's installing, I'm going to watch the events so that we can see the progress. And I'll also use Linkerd check to follow along there. Matty, is there any questions, or have you got any? Is there anything that I've missed or should expand upon?
No, there's nothing that you've missed. Maybe I would like to expand a bit on why Linkerd doesn't actually allow, a certificate that's in a secret to be mounted. And that's something that we've been sort of asked a few times, and people opened up issues on GitHub to have it done. But for us, when we use Cert Manager, when we use something else that sort of bootstraps these certificates and puts them in a secret, usually they'll have the private key. And we do not want to mount any secrets that have private keys into pods. So for us, that's a bit of a security risk. And I would encourage actually people in general who are security conscious and want to run secure workloads in Kubernetes to find a way that doesn't involve mounting secrets into the pod to do the same. Because once a pod has access to the private key, the attack surface area just sort of increases. So that's the only thing that I wanted to say. And yeah, I don't think we have any other questions. Charles has been active and helping out on Slack. We had a few questions there, but I think we can move on for now.
So, okay, all that remains is to install Linkadivis so that we can see the workloads inside the cluster, and then to install a sample application and just check that everything's working and that they are using certificates that have been signed by our certificate. There's one thing to note. This error message is, it's a false alarm. In creating this demo, Matty and I have discovered that this is a result of the Linkerd check command being a little bit too strict about the certificate, the sort of the algorithms used to sign the certificates here. The certificate authority in Venafi TPP is an RSA certificate. So our root certificate inside Kubernetes is an ECDSA certificate, which is fine for Linkerd, but it's been signed by an RSA certificate. But that doesn't matter. It's Linkerd works fine in that situation. And there's actually a pull request by someone else who has encountered this and is in the process of fixing the check command. Okay, I better crack on. So let's install Linkadivis. And just check that it's all installed properly. While that's running, I'm going to go back to the instructions. We're going to install a sample application, which I suppose lots of you will be familiar with, called Emoji Voto. It's the Linkerd like standard demo application, and we download it in, pipe it through Linkerd inject, and then apply it to the cluster once this is finished.
Yeah, the checks sometimes can be a bit long running, but at least it helps us alleviate any problems. But I have a question for you, Richard. What else can we do with the command line tool that you have for Cert Manager? Because I, for one, didn't know you had one until today. So today I learned Cert Manager has a CLI tool.
Okay. Yeah, well, it's actually, I think it's probably inspired in many ways by the Linkerd command. We've got a lot of respect for the Linkerd tools. I think we love the way you've made everything so user friendly, and so I think it's partly inspired by that. But it may or may not be around the same, have existed around the same amount of time. But anyway, to answer your question, you can use it to check the API, which I showed you already, to check the version of the Cert Manager that's installed in the cluster. And you can use it to interact with the Cert Manager approval API, which I haven't mentioned in this demo, but it's a way to set policies. Using a custom resource, you set a policy about who can sign certain certificates, who can create certificates of a certain type. And you can ensure that only certain groups of people can create certificates with certain domain names, for example. And there's a whole bunch of other policy configuration options which you can read about in the docs. So there's, yeah, it can interact with that API. It can inspect the contents of the secrets that Cert Manager creates. It can renew certificates. If you don't want to wait for the certificate to be approaching its expiry date, you can use the cmctl renew command to force the certificate to rotate. And then there's actually a whole set of experimental tools, including an installer, but I won't go into that. I better move on. Right, so we've got the Viz tool installed, and now we can install the sample application. There we go. And this is something I learned. I think this is really cool. Matty, you showed me this. We should now be able to track the connections between all of the microservices in this sample app.
Now we'll probably need to wait for them to send some traffic first, and
looks like everything is
it's
not quite ready. Not quite ready.
Yeah. Well, I have a question for you from Arthur again. Can I integrate Cert Manager with 2 external Pkis?
Yes. Yeah. You can create any number of issuers, and each issuer can be configured to connect to a separate external Pki API. So yes, definitely possible. And you can have multiple issuers within a single namespace as well. So if you have an application which for some reason, maybe you need an application which has a Let's Encrypt certificate for its public-facing web service, but needs to sign its back-end certificates using an enterprise system like Venafi, you can do that as well. So yes, definitely possible. And I think this is the culmination of the demo. Here we can see that the pods are connecting to each other successfully using TLS. And what was that other command, Matty? The identity command.
Yeah, to see certificates for a pod.
Let's take a look. Oh, N. Let's look at the web identity. Let's just see. So this is so what we've got here is the leaf certificate that has been signed by Linkerd identity. And this is the key thing. It's been signed by the certificate that we created earlier with Cert Manager. This is the subject information of the leaf, and this is the issuer information. So that's the end of the demo.
That's the
And
demo.
all of the steps are in that repository. Thanks for your attention.
That's really cool. I'm going to get into my demo now, and I'm not going to make it too long, so people don't fret. We still have plenty of time. I'm just going to steal the screen share from you, Richard.
Sure.
Okay. So you should be able to see my terminal, probably.
Yeah, I can see it.
All right, let me just quickly kill Vault. So I'm going to do a similar demo as Richard. I'll invite all of you to sort of start typing now. Well, I can't actually hear your keyboards clack, but it would be great if I could. We're going to start actually doing the same thing, but with a slight twist. So for multi-cluster environments where it might be a bit too heavy to always maintain so many layers of trust in all of our clusters and an external Pki. So because it usually tends to be a bit harder and because the configuration is a bit heavier, we're going to actually maintain a Linkerd root CA in the external Pki. So we're going to create a root CA in our Vault external issuer. And we're going to use that to only bootstrap one certificate for Linkerd, the identity issuer. And that should work across any arbitrary cluster topologies that you have, and should also sort of lessen the burden of configuration. The caveat here is that, as you'll see, it's a bit more involved, and you'll have a few more steps to automate it. So by the way, everything that Richard and I have done so far, again, just to sort of recap, are building blocks that you can use for whatever system you have or for whatever environment that you have. So this is not a one-stop solution. You can pick and mix from whatever Richard and I have done and create your own sort of solution for whatever problem you're having. But what we both wanted to do is have a way where you can install Linkerd, install Cert Manager, and bootstrap your identity without having to do it manually. Like, we don't want manual intervention. We ideally want you to put this in a script, write it once, forget about it. That's sort of the design philosophy we have it with Linkerd in general. Install it once, forget about it. Anyway, my steps are also in the same repository. Just gonna do, I'm gonna quit them just so you can see. I'm in the Git repo. I'm actually on my branch. Probably should have switched to main, but too late now. And I'm going to go into Pki Workshop Vault. So if you have Vault installed, you can follow along. If you have another Pki installed, you can probably follow along, but it just might be a bit harder. The first thing that I'm going to do is create a K3d cluster. So I'm going to use K3d. I'm going to create a cluster called, let's see, Cert. I'm just going to call it Cert. And while that is loading, I am going to start my Vault server. So when we start Vault, this is taken straight from the Vault documentation, by the way. I'm not a Vault expert. I'm actually not an expert in Pkis in general. Just sort of started working with them. For Vault, we're just going to say this is a development server. We're going to give it a root token ID of root, and we're going to bind it on all networks. So this is the important bit. We're going to bind it on all networks so we can basically address it from inside a Kubernetes cluster. And I'm going to pipe all of the output to dev null, just because I don't care about it. I'm also going to start this in the background because it has a lot of logs in there. I'm going to go back to my Vim instance. And this is where I have all of the steps, and I'm just going to keep them here in case people get lost. But yeah, the first thing I did was create a K3d cluster. If we do kubectl, and I told you to be prepared for how I pronounce it in the Zoom chat. If I do kubectl, it's version it should be version. We can see that the server version is 123, the client version is 121. So this should work for any version from 120 and above, I think. But anyway, the first thing that I'm going to do is I'm going to run a temporary shell, because we will need to resolve our K3d host. So we want to talk to Vault from inside K3d, which means we need to have an IP address for our machine. And as it turns out, the IP addresses can change. And because we are in containers on our local machine, we need to find whatever the actual host DNS names in our K3d cluster resolves to, take that IP address, save it, and then use it for talking to Vault. So I'm going to use the dig command here. By the way, if this should already be in the steps, so if you're following along, just feel free to copy it. I am going to breeze through things a little bit, just so we can also have a bit of time for Q&A at the end. But if you do get lost, let me know, and I'll slow down. I'll pump the brakes. But anyway, we can, I think it's host K3d internal, the DNS name that we want to resolve. And as soon as I do dig command, you can also do ns lookup. We're going to have this address here. So we can do a quick check. Remember that I started my Vault server in the background. You're not going to see any output from it, but it's there. So if we do the same dig short command, I'm going to use xargs to basically capture the IP address here. We're on port 8200, and Vault has a sort of status endpoint where if you send a request, so it's over here, where if you send a request to this endpoint, it's going to let you know if Vault is sealed. It's going to give you some information about it. So we're just going to use this to test connectivity between, oops, I forgot about Perl. Just going to use it to test connectivity between our K3d cluster and the Vault server. And because it returns something, it doesn't really matter what it says there, but because it returns something, we know that we can actually hit the endpoint. So yay for us. I am going to go ahead and configure Vault now. So before we actually get into everything, we need to do a bit of Vault configuration. So it's not going to be too involved because on one hand, I don't know much about Vault. So in a sense, I don't know what I'm doing. And second, we want to get to the good part, which is using these certificates with Linkerd. So the first thing that we have to do with Vault, because it's a secret engine, we have to actually enable the Pki engine. From their docs, this means we have to type in Vault secrets enable Pki. So I'm over here in the bottom right window. Let me know if I'm going too fast or if I need to slow down. And Richard, let me know if I get any questions.
There's no questions so far. I'm watching the chat and all quiet at the moment. All
right, I'll keep going. So first, we enable the secret engine, the Pki engine, sorry. Then we are going to tune the max lease to expire in 1 year. And then we are going to generate our certificate. So the way it would work in Vault is we write a new secret and we write it at this specific path. So the path will be pki/root/generate internal. We're going to give it a common name. And in this case, we want to make sure that we use the DNS name that Linkerd expects for root trust anchor, and that's root.linkerd.cluster.local. We're going to give it a TTL of 1 year. And very important, at the end, we're going to mention that the key type is ECDSA, because Linkerd only works with ECDSA key types. So we're going to press enter. Vault's going to generate some certificates. I'm not going to look at them now. I might look at them later. But just know that this is the root certificate. It has this common name, and it has an ECDSA key. So it generates the private key and the public key, which would be the certificate. The next thing that we have to do, I still have a bit of configuration left, but the next thing that we have to do is configure the Pki Urls. So because actually this is going to be used by Vault locally, we can pass in that we want to issue certificates at this endpoint, which is going to be, forget about the code, HTTP, and I'm going to go with localhost because this is for Vault's own usage, so we don't actually need to go with the machine address. We're going to also have a CRL distribution points endpoint, which is going to be the exact same thing. So just localhost and the data is written. All right, cool. The next part with Vault configuration is to generate a policy. And this policy will say that the path is anything in Pki, and we want to give it these capabilities. Oops, capabilities. Turns out I cannot spell. We wanted to create, read, update, delete, list, and also have super user permissions, so a bunch of nasty things that it can do. But we're essentially going to write this policy, write it into the Vault policy engine, and we're going to use it for tokens that then Cert Manager is going to use to talk to Vault. So basically, when Cert Manager will talk to Vault, its token will have these policies to create, read, update, delete, and do whatever it wants at the Pki path. And this is important because we're going to modify the Pki path slightly to point to a root role that will generate and sign intermediate certificates. So if it sounds confusing, it was very confusing to me at first too.
Fair play to you, Matty, for figuring all this out. It's it's amazing. Yeah.
Yeah, I'm not sure.
Earlier, when you were configuring earlier, look, were you actually configuring the endpoints that Vault would listen on for certain operations?
Yeah. So when you configure the URLs, that's my understanding of it, that when you configure these endpoints, the handlers know exactly where to go to sign certificates. When a request comes in, basically, the Vault server knows exactly where to sort of send stuff through.
Interesting.
I'm not going to pat myself too much on the back, though, because a lot of this stuff is in the Vault docs, too. So I got a bit lucky there. But now what I'm going to do is I'm going to create a token. And I'm going to pass it this Pki policy that we just created. I'm going to say we don't want any parent. We don't want any default policy. We want it to be renewable, although for this purpose, it doesn't really matter because I'm going to use it just now. But really important, we want to pass in number of uses equals 0. And as most things in engineering, this is a bit counterintuitive, but what it actually means is that we can use the token as many times as we want. So the token basically will not expire after being used 3 times or 4 times. And now I am going to create a secret. Just like, oh no, I think I still have it here. I'm going to have to copy the token. I completely forgot to do that. So we're going to copy the token that we just created. And then we're going to create a generic secret. We're going to call it my secret token. We are going to put it in the cert space. We're going to say from literal token will be this token. But before I actually press enter and execute, I forgot that I did not install Cert Manager. So what I'm going to do is I'm going to copy over this IP address because we're going to need it in a second. I'm going to exit from this interactive shell. And I am going to install Cert Manager through help. So I'm just going to let that do its thing there. And in the meantime, I can answer any questions if we have any questions.
Sorry, there is I see Arthur is asking a couple of questions in Slack. About one of the questions. They're both to do with Cert Managers, but maybe I'll answer them anyway. He asks, can Cert Manager only connect to issuers using HTTP? And I see Charles has already answered that. And the answer is it connects using HTTPS. I'm trying to think if there is another extension mechanism for Cert Manager where you can plug in your own Let's Encrypt or Acme DNS solver, and it will connect to that if you use that method using gRPC. But that's the only thing I've got to say about that, I think.
So I think it's more issuer dependent, right? Where if you communicate with an external issuer that supports gRPC endpoints, then it's very likely that Cert Manager supports them. But if the issuer itself has only HTTP endpoints, as is the case with Vault, you'll probably have to use HTTP. HTTPS.
Well, I didn't know. Is that true? Is that the case? Vault only has Vault, like TPP, has just HTTPS.
I am not sure. HTTP is the only one that I've discovered, so just gonna.
No, I'm not sure. We should check that out. I don't know. And if it does support gRPC, I don't know whether Cert Manager can connect to it using gRPC. So I'll have to go and do some research on that.
So I've installed Cert Manager, and I've also installed Cert Manager Trust, and now I'm ready to press enter, and my secret token has been created in the Cert Manager namespace. So if I do a kubectl get pods in the Cert Manager namespace, I can see I have everything here. And if I get secrets instead, my secret token is also here. So the next thing that we are going to do is, I'm in the wrong place, actually. Let's workshop. So sorry about that. I forgot to switch my path there. The next thing that we want to do is create a cluster issuer, just like Richard did in his demo. And in our case, we're going to have a Vault issuer that's going to have this path configured. So whenever a request comes through, it will send it to this endpoint at Pki /root/sign intermediate. And this is exactly why we created a policy with root permissions. Again, in a production environment, you would probably want to do things differently, but this is just an overly simplified way of basically getting everything together. And what I need to do now is copy over the IP address so we can make sure that Vault is addressable. I'm going to put the Vault port there. And we can also see that the secret token references the secret token that we just created. So I'm going to save this. I'm going to apply it with kubectl. I use an alias, by the way, and I'm sorry, I try to type out kubectl, but if I only type K, it's more of a muscle memory thing at this point. So sorry about that. But if we do, I'm going to only get cluster issuers. So I'm going to be a bit more lenient with how I verify things. So I'm just going to do get all cluster issuers, put it in wide mode. And if it's ready, then that's good enough for me. So once we have our Vault issuer, we know that we can also create Linkerd certificates. And I have to cd into this directory again. And over here, you'll notice that we only have two manifests left. So we have a root bundle, which we're going to use for the configmap, and we have an issuer certificate. So again, because we created our root CA in Vault already, all we need to do now, once we have the issuer going, is just create the identity certificate, the identity issuer certificate. So I'm going to just apply that. I'm also going to have a look at it. So again, this is just a certificate. It's just normal Cert Manager syntax. We want the key to be ECDSA. It's basically the same as Richard's own certificate that he created in his demo. The only difference is that in this case, we're just going to be using the Vault issuer that's going to get it signed by a root CA certificate. If we do kubectl get certificates in the Cert Manager namespace, we're going to see that the identity issuer is ready. Now we're ready to sort of get our config map into the Linkerd namespace. So I'm going to do that. If we look at the root bundle, this is again a trust bundle that will basically take whatever we have in the identity issuer secret. We don't have a trust root secret anymore. So we're going to use the identity issuer certificate. We're going to take the CA and we're going to put it in a config map in the Linkerd namespace. So I'm just going to apply that. And we created the Linkerd namespace too. So if we get the config map in the Linkerd namespace, auto completes, so we know it's there. If it auto completes, we know it's there. And we can see that we have a CA bundle certificate here. So just to make sure that this is the CA that we created in Vault. So we didn't create this in the cluster, we created this in Vault. So if my demo is good, we should inspect the certificate. And we should basically have the root CA. Oh, I need to save it. Inspect the certificate. Invalid pin block. Okay. Just bear with me. Must have copied it wrong then. I'm going to try again. I'm just going to delete that. Yeah, there we go. So it does work. Right. Just full screen this so it's a bit easier to see. We can see that the issuer is root linkerd cluster.local. So at least we know that it's been issued by our Vault issuer. But then if we look at the subject, we'll notice that it's the same name, and that's because it's all signed. The public key is ECDSA, and it does have a signature because it has been self-signed. And the subject alternate name is exactly what we expect it to be, root linkerd cluster local. So basically, just through the issuer and the identity issuer that we created for Linkerd, we managed to get the root from Vault. And now we have it in a config map in the Linkerd namespace. There's just one more thing that we need to do. And unfortunately, I wasn't able to do in a very automated way, but you can still automate it. We need to get the identity issuer certificate from the Cert Manager namespace and put it in the Linkerd one. Otherwise, Linkerd won't know where to find it. So I basically have the step over here. If we do kubectl get secret, we get the identity issuer secret. Well, it's not gonna autocomplete, but luckily I already have it here. We're going to do a bit of a hacky thing here. So we're going to take the secret from the Cert Manager namespace. We're going to pipe it into grep, and we're going to say, okay, don't list the namespace in the output. And then we're just going to pipe that through kubectl apply again in the Linkerd namespace. So now we have
that question. Actually, that question has just been asked. I think that point has been picked up in the chat in Zoom, and the question was any downsides in skipping the second level intermediate link trust anchor. In the previous demo, it was xCA, then linker trust anchor, then linkerd identity CA, and this is what you're dealing with now, isn't it, Matty?
Yeah. So
your method is better, but we haven't figured out yet how to automate it. And that's
yeah.
the gist of it.
So that's exactly it. So with this method, you can also always make sure that across cluster boundaries, everything is still going to work because you only have one trust root, so you don't generate certificates needlessly. But the only thing is that with this method, it's just a bit harder to get the secret from one namespace into the other. And I think it's something that we're collectively looking into. Not to say you can't automate it, because I think, doing this hacky way of doing kubectl, get the secret, don't list the namespace, apply it in the other namespace, this should work fine in a script, but it just forces you to have more dependencies. You suddenly need to pull kubectl in, whatever CI you use, and it just makes things a bit more complicated, but it's still automatable, I guess, if that's a word. So I am going to just install Linkerd with the same exact arguments that you used, Richard, and they should all hopefully work. So I'm going to do kubectl get pods in the Linkerd namespace. Everything is initializing. So I'm just also going to do the Linkerd check. It shouldn't complain about any RSA signatures now, thankfully, and also fingers crossed. You never know with these things. I'm 90% confident it's going to work.
I love this Linkerd check command. That's what we almost need that in the CMCTL command, something like this.
And also, Joe, thank you for catching another error. So in one of the steps for the Vault, and I'm also doing it here. For the Vault configuration, I use my K alias instead of using kubectl. So of course, that's going to be an error for people who do not have it configured as an alias. Just going to go through it and edit it after the workshop. But thank you so much, Joe. That's super appreciated. Cool. Status checks are all good. I'm going to install the emoji photo app as well. And I'm also going to install Linkadivis. just to quickly show that TLS is working, probably gonna have to wait. So again, another alias that I have, kubectl get pods, KGP, in the Linkadivis namespace. And we still have to wait a little bit for it to be initialized. But I'm also, I'll introduce another command here. I'll introduce edges. And this will show us all of the edges between pods in the emoji photo namespace. I hope this is up and running. Well, we still need to wait.
Matty, one thing, we have reached the end of the session, I think. But I don't think we need to stop, do we? We can carry on. And
I think we
wants
can carry on another 2-3 minutes if the audience doesn't mind. So
Great.
it should be fine. And I see that my Viz deployments are up and running. And we can now see with the edges command, the different edges between, if we have like an imaginary graph of traffic in our namespace, these are the edges. And at the end, this shows that they're secured. So instead of using tap, we can also use this command. Obviously don't trust us. If you want to dig into it yourself, you can always use tshark. But yeah, that's sort of the gist of it. Just another way to deploy it. Again, if you haven't been able to follow everything, you have the steps from both my demo and Richard's demo. You can try it with another external Pki yourself. And we're going to get those issues that Joe flagged resolved. I'm going to stop my share now. Yeah, I think we have 2 more slides, and then I think.
Yes. So I'll share my slides, my screen and slides again. So can you all see this? Can you see this, Matty?
Yeah.
Okay. So next workshop.
Yeah, next workshop is going to be on multi-cluster failover using Linkerd. So if you do want to register, the link is right over there. I'm super excited about this one because it's going to be presented by my colleague Eliza. And besides from being amazing at presenting, Eliza is also a really good engineer. So I hope you tune in. I'm gonna tune in. I think I'm gonna learn a thing or two. So that's the first thing before we end.
Yes, and this is where I should give a little bit of information about JetStack. And one thing we wanted to say is that this, I think I've said it already, but this demo is just one example of how we're trying to make the integration smoother between all of these different components. And one thing you might be asking is, Linkerd has a visualization tool built into it. Is there such a thing for Cert Manager? And there isn't an open source version, but JetStack have developed which is part of it's a suite of products called JetStack Secure. And if you are interested in that, it's free to sign up and free to use for your first cluster. And it's helpful in the same way that Linkadivis is helpful. It allows you to see quickly all of the certificates and their statuses inside your cluster. And the second thing I was going to say is that Cert Manager is an open source project. We want everyone to come and help us, help by reporting issues, help by improving our documentation, tell us about how you're using Cert Manager in production or at home. And if you're experienced enough and have the skills, then come and help us fix bugs that continually are being reported, although less and less as Cert Manager becomes more stable. And that's all I was going to say, I think. Matty.
Yeah, so with Linkerd, we also, so Buoyant, the company, the creators of Linkerd, also have a SaaS offering, Buoyant Cloud. I encourage all of you to check it out. It's super cool compared to, not having a fully managed Linkerd experience. So yeah, my elevator pitch definitely could use more work, but check it out. It has amazing graphs. You can have topology maps for your workloads, and it just makes running Linkerd a breeze. And I think that's exactly what we're aiming for, because we're in such a complex space in Kubernetes where everything is so complicated. Why not let us make it easier for you? So Check out Buoyant Cloud. If you want to request a demo, you can go to buoyant.io/demo and yeah, see for yourself. And I think I also have a call to action. We're hiring in the Buoyant team for Linkerd, so we're looking for engineers. We also have a developer advocate role, developer education engineering role. So if you want to work with me and the rest of the talented staff at Buoyant, yeah, check it out, buoyant.io/I love Linkerd. And I do love it, personally speaking. And yeah, that concludes it. Thank you all so much. And most of all, thank you, Richard, for sharing all of your knowledge with the rest of us. It's been a pleasure to have all of you asking questions and engaging with us. And it's been a pleasure to collaborate with you on this, Richard. Thank you.
Thanks. Yeah, I've learned a lot and really enjoyed it. Hope to do another one soon.
Yeah, same. All right, well, see you, everyone. Have a great end to the week. And yeah, catch you soon. You can reach both Richard and I on Slack. We have our handles, and this will be recorded. So yeah, see you later.